Hello guys, this is Paul McWhorter with TopTechBoy.com, and we are here today with lesson number 8 in our incredible new tutorial series where you are learning artificial intelligence on the Jetson Xavier NX. I'm going to need you to pour yourself a nice big mug of iced coffee. That would be strong black coffee poured over ice, no sweeteners, no sugar, none needed. I'm also going to need you to get out your Jetson gear, and I'm going to need you to get ready to learn some cool new stuff. While you're getting your gear out, as always, I want to give a shout out to you guys who are helping me out over at Patreon. It is your encouragement and your support that keeps this great content coming. You guys that are not helping out yet, think about looking down in the description. There is a link over to my Patreon account. Think about hopping on over there and hooking a brother up. But enough of this shameless self-promotion. Let's jump in and let's talk about what we are going to do today. What we're going to do is we're going to go over the solution to the homework that I assigned you in lesson number 7. How many of you guys were successful in getting that homework done? Okay, how many of you were successful? It shouldn't have been too hard because in lesson number 7, I showed you how to put one of the pan tilt servo camera controllers together, and then we already knew how to launch a camera, and so what your assignment was to be able to control two cameras, to control the pan and the tilt of two cameras, and to run those two cameras at the same time, and then to show the image in a composite window. I hope you guys were able to do that. What I'm going to do today is I'm going to take you through my solution, which might be similar, might not be as good as the solution you came up with, but I will show you my solution, and then I'll give you some homework for next week. Why do I give you homework? Because if I just show something to you, it looks easy, and you just follow along and you think it's easy because it makes sense once you see me do it. But if I'm not out in front of you, you get stuck and you really, you struggle and you struggle and you struggle, and maybe you figure it out, or maybe you're just so stuck you've got to watch me do it. But even if you can't figure it out and you're stuck and you watch me do it and you watch me do it after you've struggled with it, then that is when the learning really happens. But if you're just following along behind me all the time and never try to branch out and do things that I haven't done for you, you're never going to really learn to code. So these homeworks I think are really important. I hope you guys are really actually trying to do them. But enough of this small talk. Let me get out of your way here. And we're going to come over to Visual Studio. In this up here, I've made that window a little bit bigger because we really do want to be watching those servos move. And what you can see is I have my two version 2 Raspberry Pi cameras hooked up, and I have my two pan tilt servos hooked up. You guys should already have this. If you don't, I've got links down in the description so that we can be working on this identical gear. I will need you to call up the most excellent Visual Studio code. We will be going with a gray background today. We will be going with a dark background, and there is no consensus. Kind of like half of you like the white background, half of you like the gray background. To me, the dark background just has more contrast and it's easier for me to see, so give me your feedback. I'm not locked in on this, but it seems like some people just really hate the bright white background, and so we'll continue to try to work towards getting the most visible Code Studio window to try to make everyone happy. But again, enough of this small talk. Let's open up our Explorer view. We are working in the OpenCV folder. And in the OpenCV folder, I have, last week we did simple servos. So we will have a new program this week. And it is going to be open, how did I do that? Like open CV, and this is going to be -4, and then we're going to say dual cams like that, because we're going to have two cameras. Hit enter, and then I did not put the .py on there. You know how I'm always telling you guys how important the .py is, and I didn't put it on there that time. So let's see if I can do a rename, and I will put the .py on there because that actually is really important. All right, need to do a little Windows management here. And now I think if I close this, you guys should have a pretty good view there. We'll see if you can see that. If it doesn't work, I'll go to the smaller picture in the larger window, but I'm hoping this will work. Okay, let's start with a working camera program, and you can get that. You guys probably have saved this, but if you don't have it, you can start by going to the most excellent www.toptechboy.com and search on Jetson Xavier NX Lesson 5, and you will come down here and you will have this nice little snippet of code. Hit the two little windows. It will select it, right mouse click copy, and the nice thing about this code is it has that improved GStreamer string so that we launch the camera where it's looking really good. So we will come back over here, we will right mouse click, and we will paste it. And I always like to just start by running this program, making sure that everything is hooked up right. I should have one camera running here if I just run this in the terminal. Boom, look at that. Okay. Hello. It's on those servos and they're pointing a little bit down, but that is really looking good to me. It looks like that is the camera that is on my left, the camera that is on my left right there. Okay, so that looks good, so I'm going to kill out of that. And I think the first thing that we ought to do is try to get both cameras working. So I'm going to take this cam set and I'm going to make that cam set 1. Okay. And now, as you probably can guess, I'm going to have a cam set 2. So I'm going to take this and I am going to copy it. And then I am going to, man, I don't know what I just did, but it's like I hit delete or something. Undo. Okay. And so I'll select it again and Control C. That copied it. Right now I'm going to enter and go up and Control V, and I will make that, can you guess, I will make that cam set 2. But if this first one is sensor ID 0, I better make this one sensor ID 1, and then we will leave the other parameters as is because the camera should be pretty similar, so I think that would work pretty well. All right, so we've got the two cameras set up there. Now here where we create cam, we are going to create cam 1, and that would be on cam set 1. And then can you guess what we're going to need to do now? We're going to need to create cam 2. So I'm going to do a Control C, a Control V, and this will be our cam 2. And then this will be our cam set 2. So I think at this point we should, if I'm thinking right, we should have two cameras. But now if I'm going to do that, I'm going to need to do a read of cam 1, and I will put that in frame 1. And now we are going to copy this. And then you see I'm just migrating this from one camera to two cameras, right? And I'd like to really try to make things parallel, so I don't want to have the first one called frame and then the next one frame 1. It's just like if I'm going to number things, number everything. There's cam 1, there's cam set 1, there's cam 1, there's frame 1. Then there's cam set 2, cam 2, and frame 2. You see, it's just if you make things kind of symmetric like that, it's a lot easier to debug it. So this is going to be cam 2, frame 2, and then this is going to be cam 2. All right, and then I'm going to CVIM show cam 1 will be frame 1. And then let's go ahead and just for good measure, let's put in a second one where we'll show cam 2. I like that background. That's looking very high contrast to me. I hope you guys will let me go with the gray. But I am here to do what you guys want, so if enough people hate it, I will go back to the white. Okay, so now CV2, my window cam, and then I guess I can say that would be cam 1. And then we're going to do this, Control C, Control V. And then we're going to move window. Now this one is cam 2, and let's move it like down 500. And then I think I need to probably change this. Let's say I made it 640 by what do you think? Would that be 360? I hate doing math in my head, but let's see if that'll work. Just because we're going to have two windows, I need to make it a little bit smaller, I think. Run Python file in terminal. I need to have a cheat sheet of like, boom, look at that. I need to have a cheat sheet about what all the different kind of like combinations could be. And so let's see here. I've got a little bit of latency, so we need to take a look at that because I should not be having latency at this point in the game. And so let's look up here and let's look over here, and I do not have very important things. I want to say drop equal true because that should help me with that latency problem. And I think it's an uppercase T, but if that doesn't work, we will know what it is. Drop equal true, like that. Okay, and you guys could see that. What I found is you don't have to do the latency. You don't have to do the threading for the latency if you just say drop equal true. And what that's saying is, hey man, if you start getting behind, just drop those frames and get caught up. Otherwise, it starts filling a buffer up. And if you fill a buffer up, then you don't lose any frames, but you get out of sync. And when we're doing real-time object detection and robot control, we don't want any latency. So let's try that. I'm having fun. I hope you guys are having fun. Let's see. Shazam! Shazam. Do you see that? Do you see that? Okay, let me make sure I got two different cameras and I'm not just showing the same one. Okay, yeah, you see that and then that. Yeah, so I'm getting both cameras. So that is good. Man, we're making a lot of progress. Now what I think I want to do here is I want to go ahead and stack. Let's see. I think I'm going to make those a little bigger. Maybe I will make them a little bigger. I think I'm going to do 720 by 480, like that. And then let me just see if that looks reasonable. Make those a little bit bigger. Okay, I think we can manage those. I think that'll work. A little bit bigger images. All right, so that is very good. Let's see what other things we might want to do here. Let's go ahead and stack them into one window because I think that was part of the assignment, that you create one window where they are stacked together. And so let me do a tad bit of Windows management here. Man, I wish I was a real player and had like someone in the control room. Do you realize how hard it is to be thinking about what I'm coding and then at the same time having to be talking and teaching and at the same time managing my control room? And so that's a lot of stuff to be trying to keep track of at the same time. But let's see, I think what I will do here is I want to create a frame 3, okay? And I want to do it before I start showing my window. So what I'm going to do is I'm going to say frame 3 is going to be equal to np dot horizontal stack h stack, and then what do I want to stack? I want to stack frame 1 and frame 2, like that. Now if I do that, what I am going to need to do is I'm going to need to import NumPy. Okay, so I'm going to say import NumPy as np. And then that should stack those two together. And notice that it's kind of strange, but it wants a tuple. So I have to put parentheses around the frame 1 comma frame 2. And then you've got the kind of call parentheses. You sort of have two parentheses there, which I would not have just guessed if I had been guessing. Okay, so now probably what we need to do here is we need to, I am not going to show CV2 and I'm not going to show CV2, but I will put a new one in, Control C. And can you guys guess what I'm going to do here? It is going to be not my cam 3, not my cam 3, wait for it, it's going to be combo cam, like that. And it will show frame 3. And then down here, I do want to move. I'm going to get rid of this one. Okay, I do want to now move combo cam. I do want to move combo cam, and moving it down 500, I want to get it below this picture up here of the Raspberry Pis. I mean, of the Raspberry Pi cameras. I want to get it below that. And so let's see if this will give me a nice dual window. Boom! Do you see that? Now, when we actually start doing this, I can get out of your way a little bit so you can see both of those. But I think that's pretty good. The only thing is that's a little bit further down than it needs to be. And so I think I will tweak it. And I think that we will make this, let's say like 450, something like that. I'm just going to try that real quick. Man, we're on a roll today. I'm like smoking hot today as far as getting this coding done. I don't think I've had a program crash yet. And look at that, very nice alignment up here. And so also, man, I still love that quality that we're getting with that better GStreamer command, and still no latency. All right, synchronized cameras. But man, I am having fun here. I love doing this. And you guys are nice. I like having you as subscribers. It's like I've got 150,000 friends out there. I really like being able to work with you guys and have a lot of fun. Okay, so now we've got that done. Let's go ahead now, and I think what we need to do is get ready to do our frames per second, because I always like to put the frames per second on there. And so what we'll need to do is we will need to go up to the top and grab a time mark and make sure that we're importing time. And so I'm going to come here, and if we're going to do delays or time, we need to import time. And so that looks pretty good. And after we import time, then we're going to come down here and just go ahead and grab a time mark so that we have one to begin with. We are going to grab a time mark, and that is just equal to time dot time. That is simple enough like that. And then we're going to come down here, and I guess we probably need to set up a couple of other things. We're going to need to kind of initialize some, parameters if that is going to work right. Because, you know, the first time through the loop, you need a value to be there. So I'm going to say my DT filtered. Yes, we will be using a low pass filter. So DT filter, that means the change in time that occurs once through the loop. And then this is the filtered value, and we're going to set that equal to 0 just to give it something to start with. And then we've got the width, and we have the height. So that looks good. And let's see. We will come down here now, and we will need to calculate our frame rate down in the loop. We will need to calculate our frame rate down here. So we will do that kind of like after we put the frame together. So we'll go ahead here, and we will say now dt, the change in time, is equal to time dot time. That's the time now, minus the time last time is time mark, but we kind of seeded it with the first value up top. Okay, but now we need to get the time mark for next time around. So time mark, putting this aside for the next loop through, we're going to need a new time mark, is equal to time dot time. Okay, that looks good. And now we are doing a low pass filter, so we're going to say DT filtered is equal to 0.9 times the old DT filtered. So we never trust a new measurement. It's got to kind of show that it's trustworthy. So we put 90% confidence in where we were before and only 10% confidence in what the new reading says, but then over time we always get the right reading and we don't have a lot of noise. You guys, I hope you understand a low pass filter. It is a very powerful concept. And I don't know if you guys know this, but did you know that you can actually do a low pass filter in hardware, or you can do a low pass filter in software? Here we're doing a low pass filter in software. So the two weighting factors have to add to 1. So if I put 90% confidence in the existing value, I will put 10% confidence in the new value, which we just set up there, dt. Okay, and so now I have a DT filtered. That's how long it takes to go through the loop one time. But I'm not interested in that. I am interested in the frames per second. So frames per second is 1 over this DT filtered value. So if it takes 1/10 of a second to go through the loop once, then I can do 10 loops per second. And since this is reading a frame every time, that would be 10 frames per second. I genuinely hope you guys understand that, because it is pretty important. Frames per second is equal to 1 divided by DT filtered. And make sure to use the filtered one. Okay, and I'm just going to print that. I just like to run this thing before we do too much stuff. Oh, and I think no, I think that's right. So print FPS comma FPS. Okay. So that is just going to calculate it, and then it should print it down here just to see if it's reasonable. It should be 21 frames per second, I think, because that's what we set the camera at. Okay, and then let's see if I can bring this up. Okay, yeah, 21 frames per second, so we are getting good values there, and I can quit out of that. Man, you know, I don't think I've made a mistake yet, so now all of a sudden my obsessive compulsive nature kicks in, and my internal goal as I'm doing everything else is to not have an error for this entire lesson. That's what my goal is. All right, so that's what I'm thinking. I don't want to have an error for this whole lesson. Just one of those crazy little ways that my mind works. Okay, now this is going to be the hard one. This will indeed be the hard one, because what I need to do now is I need to put that frames per second on the image. So I'm going to say CV2. I'm going to give like a background, like a red background to write on, so you'll be able to see the frames per second no matter what is in the picture. So I'm going to say CV2.rectangle, and then what do I want to put it on? Well, frame 3, of course, because that's the one that we're showing. And then where do I want to put it? The upper left corner is going to be at 0, 0. And that is a tuple, meaning it's in parentheses. And then I think I'm going to go over let's go over 150 and down 40. And so that'll be big enough to see. So that will be 150, 40. All right, I think that will be a nice background. Now we need to give it a color. I'm going to make it red, 0, 0, 255. Why is that? Because OpenCV is chosen to run in blue, green, red, and so the last number we put in is red. So that should give us red. And then I want it to be a solid box, so I put a line thickness of -1, and that should make it a solid box. Okay, I'm getting overconfident. I'm going fast, and I'm going to mess up my goal of not having a crash for this entire video. Okay, now I need to actually put the text on there, so I will do a CV2.put text, and you guys that watch me know that this is the most likely command that I will mess up, is the put text. I'm going to put text on what frame? Frame 3. And then where do I want, or what do I want to put on there? What do I want to put on there? I want to put, in quotes, FPS, like that. That's just the label. And then close that quote, and then I concatenate it, which is the add. That means add this string to the end of that string, concatenate that with, and so I'm going to open another one. I've got to make it a string. What do I want to make a string? Well, I want to round, because that FPS has like 20 decimal places. I want to round it to, and that should not have, because this is a string, so I don't put the quote there. So I have str of round, and what do I, and I got to get rid of that one too. That round, what do I want to round? FPS. How many decimal places do I want to round it to? 1. Okay, and now I close the round, and then I close the string like that. Okay, now where do I want to put it? I want to put it at 0, and then I want to put it down 30. and that way it's not half off the screen. You got to pull it down a little bit or it won't all show up. So I'll put it about 30. Okay, and now I have to give it a font. Keep in mind, font has not been defined up there, so we got to go up and tell it what font is. We got to take care of that. I'll have it a size of 1, and then let's give it yellow as a color. You guys know what yellow is? Ooh, and I almost missed that comma. Okay, yellow is going to be 0, 255, 255. So that would be mixing red and green together. Mix red and green together, you get yellow every single time. Okay, and so now we got to give it kind of a heaviness of the font, and I will give that a 2, like that. All right, I better actually look over this because I'm going to just be sick if this thing crashes. All right, now the one thing that we remember that we have to do is we've got to define font up here. Okay, so I'll just do that. I'll do it right after the flip equal to, and I will say font is equal to CV2 dot, what do you guys, I don't know, I'm just like, I don't get too excited about all these fonts that they offer, but font Hershey Simplex is I think what we do. Font, and look at that, man, my autocomplete is really working. Font Hershey _ Simplex. This somehow sounds like a disease. This font sounds like a disease. Okay. I don't know what it is, but I'm glad I don't have it. All right. Font Hershey Simplex. That looks good. Okay, guys, let's see if we can run this thing. Boom! Look at that. 21 frames per second. Giddy up. Giddy up. All right. Man, we're on a roll here. I feel like this is going really well. I mean, there's nothing new or all that complicated, but we've got a window, and in one window we're showing both cameras. All right, now what we need to do is we need to get the servos working. So I'm going to come back over here, and I got to start getting ready to make those servos work. So in the last lesson we installed the Adafruit servo library. If you haven't done that, you need to hop on back over to lesson number 7 and get that library installed. But we have it installed, and so we are going to import it. So we will say from Adafruit underscore servo kit, from Adafruit underscore servo kit import, and I'm going to call it servo kit. No, I'm sorry, I'm not calling it that. That's what it is. That's what we're importing. This isn't creating an object. This is just saying what part of that sensor library we want to import. All right, so that is what that is doing. So now I'm going to come down here and kind of get a spot. And I like to put some blank lines in my code, just kind of functional blocks. I like to put a blank line between because it kind of helps me debug it later. So what we're going to need to do is we're going to need to go ahead and create our servo kit. So I'm going to call it kit, and that is equal to servo kit. All right, now I got to call kit what I wanted to. So I called my servo, I called it kit. And then what I need to do is tell it how many channels. And that board that we are using has 16 channels, and you should know that from last time. Okay, so kit is equal to servo kit channels is equal to 16. All right, now this is the one little tricky thing. You might think I've got 2 servos. I need to create 2 different objects, but really this kit is talking to the board, okay? And we have one board, and therefore we just have one object, and then it's the board that controls the 2 different servos. I hope that makes sense. But like the first time you do it, I think your intuition tells you need to create 2 because you got 2 servos, but no. You talk to the board, one object, one board, and then the board talks to the two servos. I'll show you how to keep that straight here in a minute. We probably are going to need to put some values in here, and so I'm just going to start with a tilt is equal to 90. Okay, and then I'm going to set a pan is equal to 90 like that. And now what I think we can do is we can go ahead and position those servos. We can position those servos, so I'm going to say kit.servo. The first servo in that first position is servo 0, and remember I told you to put the pan in that first slot. So kit servo 0, okay, that's the first one, kit servo 0 dot angle, we're going to set equal to pan, which should be 90, which should sort of be in the middle, okay? And then I'm going to say kit.servo 1 dot angle is equal to, that would be tilt, okay? Now what we are going to do is we are going to position the second one now, kit.servo. This is the second pan tilt, and so that would be position 2, which is the third position, dot angle. That is going to be pan again because we went pan, tilt, so that will be pan. And then I'm going to have kit.servo of 3 dot angle is equal to, this one's a tilt, so that's the tilt on the second one. So let's just run this, and you guys just be watching those things and see if they move. Let's just see if the program even runs now. Man, I forgot to check things, and remember my goal is to not crash anything. Okay, this is running slow now because, right, it takes a while to load that library, that servo library takes a second. Boom, okay. And I definitely saw those two cameras move when we did that. So we are smoking hot programmers today. We are. Look at that. Okay, so let's quit out of this thing. Now what we got to do is we've got to start making some magic happen. And actually, this turned out to be a little bit harder than what I thought it was going to be, because what I thought is, I thought that, you know, like I just thought, okay, I'm going to have a for loop, and the for loop is going to do a pan, and then after that for loop, I'm going to have a for loop that does a tilt. So I would just be going back and forth and then up and down, and maybe one camera and then the other, or maybe having them go together. But what you realize when you get in here, your main timing has to be done by this while loop that is grabbing a frame every 1/20th of a second, okay? That has got to control your timing. And if you go off into a for loop where you're moving the servo, you're not grabbing frames and your frames are building up on you. So you can't use a for loop where you grab control of the program and be moving the servo like that. You've got to have the servo motion inside of the while loop, where the guy that's really in charge is your main wheel. Your main wheel is grab a frame, show a frame, grab a frame, show a frame. We have to slide the servo motion in the middle of that without messing up our timing. I hope that makes sense. But initially what I thought I'd do is, okay, well, I can do a camera, I can move a servo with a for loop, now I'll just put them together, but it turned out to be a little bit harder than that. And so what I think we need to do is we need to create two different things. And this was sort of like when we used to do the bouncing box, and like how far do we want to move? Well, I'm going to create a, here, like I've got tilt and pan. Well, I'm going to create a D-tilt, and that's the change in tilt, and I'm going to set that equal to 1. And then I'm going to set a D-pan, and I'm going to set that equal to 1. So each time, now I can just say pan is equal to pan plus 1. As I'm going through the loop, just pan is pan plus 1, and each time it will move a little bit without messing up the camera timing. So let's see if we can do something simple down here. So let's say after we show that and move that window, now let's do a little servo action. Okay, we want a little servo action. And I'm going to start just with the pan. Okay, so I am going to say that what I am going to want to do is I'm going to say kit.servo, and what is my pan one? Well, it's 0. and kit.servo.angle is going to be equal to pan. That's simple enough, right? Now what's my other pan one? Kit.servo of 2, right? 0 and 2 are pans, and 1 and 3 are tilts. And so I'm going to come over here, and that is going to be equal to pan. So I'm going to be moving them in tandem. Now you could get fancier, and instead of having them move together, you could have them go cross-eyed or wah-eyed or, you know, googly-eyed or whatever, but we're just going to do the simple thing here. Okay. And then, so those are equal to pan. Now probably what I need to do is say pan is equal to pan plus 1. All right, so each time through the pan is, or not plus 1, because then it would crash into the edge. So it's got to be pan is equal to pan plus pan, or what do we call it? D pan, I believe, like that. And let me just make sure that's what I called it up here. D pan and D tilt, just like that. Okay. So now I've got to deal with the issue of, like, when it gets to 179 and now 180, I don't want it to add 1. And so I don't want it to crash. So I need to say if pan is greater than or equal to 179, just to be safe, or if pan is less than or equal to 1. So I want to stop before I kind of run it all the way off the edge. What do I want to do then? Oh, what did I just click? Thing went crazy on me. Okay, so what do I want to do here? I want to get in the right position. Man, this is kind of strange. Let me... Okay, there. That looks good. So what I want to do is I want to say D pan is equal to D pan times minus 1. And I'm a math teacher, so man, I can't write times minus without putting the parentheses in there, because it's just, from a math perspective, it's too confusing. Here it's clearly D pan times a negative 1. Okay, now why do I do that? So when it gets all the way to the end, then it'll increment back the other way, and then increment back the other way. You guys, if you took the Jetson Nano lessons, this should be pretty familiar to you. Okay. And so I put the pan on it, and then I make sure that I'm not going over the edge, and then I loop again. Let's see if this thing works. Man, I am so scared. I am so scared. Hold your breath this time. Don't crash. Don't crash. Don't crash. Don't crash. Don't crash. Boom! Look at that. Shazam. Look at that, guys. We are moving those things. We are moving 2 servos. We have dual signals coming in. 21 frames per second. Giddy up. Look at that. All right. Did you guys get this far? Were you able to make that work like that? That is just really super cool, if you ask me. I'm just going to sit back. Do you ever just want to sit back and bask in your accomplishment? Now, the neat thing about me is I get excited about this, and then I have all of you guys to get excited with me, and then it makes me happy that you're excited for me that my program works. If you guys are sitting at home, do you have people that you can share your success with? Or is your wife or husband or whatever, are they like, oh man, I don't want to hear this anymore. You know, I don't care about your boom. Stop going boom. Do you guys actually go boom when your program runs? Do you hold your breath when your program runs? Inquiring minds want to know. But this is just really neat. And then you see up there the camera. I think that's really neat that we're able to watch this in the camera. This is super, super cool. Okay, now what I had initially thought to do was just increment tilt and increment. So like I'm going to increment tilt, I'm going to increment pan. But if you do that, what happens is it kind of goes googly-eyed. It kind of goes every which way that it's going up and over at the same time, and I found it very distracting. I did not like that at all. I'm trying to look here. Do I have dead pixels on those cameras? I think I do. I think I've got dead pixels on those cameras, and that does not make me happy. Let me see if those move. Yeah, I think they move. I'm counting dead pixels on there, which makes me mad. Okay, I am going to quit out of this thing. And so now what we need to do, oh man, now the pressure is on because I have made it this far without having a program crash. And now it's like obsessive just kicks in. I am going to make this whole video, probably the first video I've ever made where I didn't have an error. This is going to, today is going to be my day. Okay, so now what we want to do is we want to deal with the tilt. But again, I don't want to be going like this. What I want to do is I want to go back and forth and then increment up, back and forth and increment up, back and forth, increment up. And then when I get all the way up, back and forth, down, back and forth, down. So it's sort of like scanning. And then what it kind of gave me the idea is that by doing that, when we actually start doing the artificial intelligence and the object detection and recognition, we could kind of scan the room looking for something, and then when we find it, then we can lock onto it. And then, wow, that's like really exciting. So I don't want to go randomly. Now we will eventually want to control the right camera and the left camera separately, but it would just be adding like pan 1, tilt 1, pan 2, tilt 2. That would be really easy. But right now, what I want us to do is just see if I can kind of scan. All right. So in order to do that, now I've got to do something with tilt. Well, I only want to do tilt. I only want to do tilt is if I am at the end. So when I get all the way to this end, I'm going to increment, or when I get all the way to this end, I'm going to increment. So where would I want to do my incremental of tilt? Well, if I did it here, what's going to happen? It's going to go over, up, over, up, over, up. Where do I want to do it? I want to do it inside that if statement, and therefore I only want to increment tilt if my pan is at the limit of its travel. So right here, what I'm going to say is tilt is equal to tilt plus d-tilt. Okay, tilt is equal to tilt plus d-tilt. And then in this particular case, what I will do is I will say kit.servo. And which servo am I going to deal with this time? Which servo am I going to deal with? It's going to be servo 1. Okay, it's going to be servo 1 dot angle is equal to tilt. Okay, and now I'm going to say kit.servo, and which one is going to be 3 dot angle is equal to tilt. And so those two, if I get in this if statement, then I will move the servo, and then otherwise I'll go back and forth, and then I'll move that one. So I only increment it and only move it if I'm in this if statement. But now I also have to make sure that I haven't gotten too far up or too far up or too far down. And so I have to do an if statement inside of this if statement to see if I've gone all the way up or all the way down. So I will say if tilt is greater than or equal to, what did we say, like 179, I think. Okay, 179, that looks good. Or if tilt is less than or equal to, I think I'll put it at 1, like that. Okay, and what do we want to do? We'll d-tilt equal d-tilt times -1, like that. All right, and then still what I need to do in here, what I didn't do yet, is I've still got to increment the count. I checked what the count is, but I still have to increment the count. And I do it here. I incremented the count. I incremented the count. I did that right there. Okay, I forgot that I'd done that. Oh man, what is the chance this is going to work? This is going to destroy my day if this doesn't run, because I've got this crazy internal goal that doesn't really matter, that all of a sudden my whole world revolves around making one video without a mistake in it. It's kind of like pitching a no-hitter. Okay, here we go. Run Python file in terminal. Please run. Please run. Please run. Don't crash. Don't crash. Boom. Okay, but we can't get too excited yet, because does it increment? Okay, does it increment? I'm not seeing it increment. I don't think I saw it increment. Okay, but the program didn't crash. Is it incrementing and I'm just not seeing it? Like it's just doing 1 degree? I still think that I should see more than that. I think maybe what I need to do is I need to make that when I'm going to quit out of this. I'm going to still say the goal was not to crash, and it didn't crash. So what I'm going to do is I'm going to put the D tilt at 5. So it'll hop up by 5 degrees at a time. And where was that D tilt? I'm going to put that at 5. All right. And then I'm going to come down here. And now I better check, instead of 179, I better go 174. And instead of 1, I better make it 5, like that, so that, again, I don't run out of range on the servo. So now let's see if we can actually see something. Okay, it is running, but is it going to increment is the question. Ah, I am sure I saw those things tilt up that time. Boom! Do you guys see that? Are you guys having a... I don't know if I'm just easy to get excited, but this is really exciting to me. I hope you guys are doing this, and I hope you can call someone in to show you what you have working here, because it's like I feel like James Bond, right? I'm scanning the room now. I'm scanning the room. This is really neat. Okay, I'm going to speed it up a little bit, so I'm going to quit out of this. And I want to kind of see it get to the limit. And so I'm going to go ahead and make D tilt 10. So it'll go quicker. D tilt is 10. But just remember, when you do that, you need to come down and adjust this. And so this would be, if I have 10, that would be 5 more. So that would be like 169. 169. And then this would be, let's say 11. So that would always put it at 1 and 179, so it would not hit 0 and 180. Okay, let's run Python file in terminal, and let's see if this thing works. Man, this is fun. This is really fun, because it's like my mind is going crazy in all the directions we're going to be able to go, where we add to this facial recognition, and we add to this object detection and image recognition, and we can look for something. We can search the room for it, and then we can track on it when we found it. And that probably is going to require us to kind of like do some threading and some other interesting things like that. Wow. Hey guys, I did this without making a mistake. I didn't crash the program. Can you believe that? This is so cool. Let's see if we can zoom in a little closer on this. Let's get our observation camera, and you know guys, I have just gone to manual focus because I fought with this so long. Okay, that is really good focus. Okay, all right guys, we are running at 21 frames per second. Okay, now when it gets all the way up, I want to see it go down. And you guys, make sure that your cables are not getting in a place that it's going to pull the cable out from it. So you got to do a little bit of cable management here. And so let's see, those are going to go almost all the way up to the ceiling. And oh, they're coming back down now, and so that is good. I want to see that they go all the way down and then come back without crashing or without running into the bracket. That's the next thing that I want to see. And again, let's check our latency here. I'll wait till it comes back around here. I want to make sure that we don't have latency. No, we don't. Those are perfectly secure. Man, this is exciting. I am having so much fun. Yes, I have hot coffee and I have cold coffee, both. Those just, I really like my coffee. Because I am just so impressed with this these little servos, and kind of like the whole thing for 20 bucks. I thought that was a pretty good deal. The one kind of unfortunate thing is that the Jetson only likes the version 2 Raspberry Pi camera. I wish that it would use the version 1, because then we could pick up, you can find on Amazon, you can find some of those cameras for like 10 bucks, the version 1 cameras, but we got to pay a little bit more for these version 2 cameras. The other thing is Raspberry Pi came out with a high resolution, a new even better camera. A new even better camera, and I am just really super eager to get one of those and hook on here. And those have attachable lenses that you can use, and so I am just really excited to get one of those and try it. But the problem is I haven't seen anybody confirm yet that they'll run on the Xavier, but when they do, I will be picking up a couple of those cameras. All right, we're kind of like inspecting the top of the table here. Not very interesting, but we should be getting close, I think, to the thing turning back around and going up. And I'm sure you guys are seeing that you gotta just be careful with those cables, because if the cable grabs on something and the pan keeps going on, it could yank the cable out of the camera, and that would not be a good thing. That would not be a good thing. Let's see, I want to see it turn around. Okay, now it's turning around. It is coming back up. Okay, guys, I had so much fun today. So what I want you to do for your homework for next week is we've got this functionality locked in, okay? We can move the cameras where we want, and we can handle 2 images at the same time in one frame. That's like a really strong foundation. And we will be using this extensively in the future. And so make sure that you save this code, and I will put it up on my website, www.toptechboy.com. I'll put it under lesson number 8 so that when we get to 9, we could come back to where we are here. What you could do is you could go in and you could move one camera while the other one's still, then move this one while this one's still. You could kind of work on independently controlling the cameras. But that's not your homework. What we're going to do next week is we are going to train it on contours. And so you guys, if you went through the Nano series of lessons, you'll know how to do this. But that was a long time ago, so you need to review this. So your homework for next week is to track a pin, not with the servos. You don't have to use the servos, but you just look at the scene, and I want you to look at a scene and be able to find and box, like on me, this blue cap on the pin. Okay, you don't have to track it with the servos, but you have 2 cameras, okay, and then those 2 cameras, what I want you to be able to do is I want you to be able to find and box the pin, and you won't be moving the servos, because you got to figure out how to do the contours, and you got to figure out how to do the bitwise mapping and the thresholding, and it's going to take track bars, because you're going to have to use the track bars to find it. But get that working, okay? And really, at this point, everybody's just looking for a blue pin, okay? Everybody's just, left camera's looking for a blue pin, right camera's looking for a blue pin, and then both of them put a box around it. And I think that will be challenging enough, because what you can imagine, the thing that you're going to have to do is The camera on the left here is going to be easy because it is got the right coordinate system. But if you're going to box something on the right camera would view this as the center of the image, but that's not the center of the window. So you're going to have to kind of offset things on that right one to get your box drawn in the right spot. And that's going to be enough to keep you busy for the next week. And so where do I see it going? I mean, it can change, but where I see things going is next week when I put this pin, I want both windows to draw a box around the pin. Okay, and again, the servos are not moving. It's just you draw a box around the blue pin cap. Okay, then what I see the week after that, what I see you doing is I see you moving the servos where the servos track the blue pin, keeping the blue pin in the center of the field of view. All right, and then what I see you doing after that, then the following week, what your homework is going to be is you're going to have a blue pin and you're going to have a red pin, and one camera tracks the blue pin and the other camera tracks the red pin. Okay, that's kind of what I see would be really, really interesting. And then, darn it, guys, I still have the problem. I want to get the little Raspberry Pi streaming live video to the Jetson Xavier, and darn it, I can have this little thing streaming using a GStreamer launch. I can have this streaming to the Jetson Nano, but for some strange reason, I cannot have this streaming wirelessly to the Jetson Xavier NX. And so what I'm hoping is one of you show-offs out there would figure that out and let me know how to do it, and then I could send the solution to everybody else. I'm just really kind of very busy right now because I'm making the Elegoo Smart Car series. I'm finishing up the Jetson Nano series. I'm doing the Xavier series here, and then I've got to clear off time to start working on the JetBot because I know a lot of you guys want to do the JetBot. And so something like figuring this out could probably take a day or two, and it's just a day or two that I can't take away at this point. But moving forward, man, imagine if we had a wireless camera on those moving servos, and therefore we are not tethered to the mothership. We're not tethered to the mothership by these cables. We could have these little units all over the place with a Raspberry Pi Zero camera, and then scanning the room for an object of interest. And anyway, that is where we are, and I am having so much fun. Hopefully you guys are enjoying this. You guys, if you want to hook up with me on Facebook, I can't answer every single private message I get, but you can search on Paul and Anna McWhorter. Send me a friend request on Facebook. Also, I'm on Twitter at Paul J. McWhorter. Think about sharing this. Think about sharing these lessons with people. I hope we can get more people involved with this. If you like the video, give me a thumbs up. If you don't like the video, get lost. No, just kidding. If you like the video, give me a thumbs up. Think about subscribing to the channel. Share this with other people. This is Paul McWhorter with TopTechBoy.com. I will talk to you guys later.